the next graph that we're going to do is going to use the same data as the first. That data being, Harry and Ron went for a walk 10 days in a row. Every day they counted how many dragons they saw. They saw 5, 7, 4, 4, 6, 8, 7, 3, 5, and 4 dragons. But only now we're going to create a circle graph. The best thing about circle graphs is that frequency tables, which we had created before with the same data, is almost always used to create a circle graph. So in this case, we can use both our data and the frequency table that we created before to create our circle graph. So the first step being, we know that it's a circle graph, so we're going to need to draw a circle. So we'll draw a circle. And it doesn't need to be perfect, just look like a circle. And so now what we're going to do is going to figure out a way to divide all of our data into our circle. So we first look and we see that none of our data specifically says that they saw 6 dragons 5 days out of the 10 that they went walking. So nothing here says 5 days, so we know that it won't be a half, but we can find things that can equal up to a half, so we can first work on portioning our circle. So right off the bat we see that 3 plus 2 equals 5, and that equals half, and then 1 and 1 and 1 is 3, and then another 2 is 5. So we'll focus on these two for now, but we know that that equals half, so we'll draw a line down the middle of our circle to show that that is half of our circle. And because we know that a fourth would then make these two pieces even, but because we have one more number than the other, or one less number than the other, we know that they can't be fourths. So we don't want these pieces to be even, but we want one piece to be a little bigger than the other piece. So we're going to start off by creating one piece that happens to be smaller than the others, so it's distinctly noticeable, but it's not too much larger. And we'll write our 3 in here and our 2 in here. And this stands for how many times they saw that number of dragon throughout the course of the 10 days that they went on their walks. So now we know that this piece equals 2, and we see that we have one other number in here that equals 2 as well. So we're going to mirror on the other side as best as we can and draw another portion of the circle that equals 2. And on the outside, because now we have 2 of the same numbers, we're going to draw 4, or we're going to write the number 4, and then here, for the 2, we are going to write the number 5, and this will stand for how many dragons they saw. And then down here for the 3, we will draw the number 4, and they saw 4 dragons on 3 different days. And then over on this 2 will be the 7, meaning they saw 7 dragons on 2 different days. And then we now see that we have 1, 1, and 1 left. And 1 plus 1 plus 1 equals 3. So now what we have to do is we just have to portion up the mirrored piece of the 3 into 3 equal parts. So we'll just split these up into 3. And if they don't line up immediately the first time, that's okay. You can erase them and make them more proportioned so that it fits the data that we are using. And then we can fill in the numbers after they're all equal, because that's a very important piece with our circle graphs, is making sure all of the pieces are equal. So we'll have 1, 1, and 1. And then on the outside we'll do the same with the rest of our numbers here, so we know what each one stands for. And this one will be for 3, this one can be for 6 dragons that they saw on one day, and this one can stand for 8 dragons that they saw on one day. So if we were to go through and add up all of the days, we would see that 1 plus 1 plus 1 equals 3, 3 plus 2 is 5, 5 plus 2 is 7, and 7 plus 3 equals 10. So these are